morning, students. We are here to study about the BBS of Retaining Wall. So this question has already been given to you. Prepare the detailed estimate of an RCC cantilever retaining wall for a length of 30 meters from the given figure. The weight of 10 mm diameter bars is 0.62 kg per meter, 12 mm bars is 0.89 kg per meter, 16 mm bars is 1.58 kg per meter, 20 mm bars is 2.47 kg per meter. So when the weight is given in kilogram per meter, it is easier for you. You need not know the density, you need not find the volume. You just need to know the length of the bar for each different diameters. Okay, so once you know the length, you can multiply it with this value and you will get the weight of the bars. Okay, and along with this, the rates of the shuttering and centering has been given and the reinforcement rate has also been given. Okay, from the figure it can be seen that the stem cover and the base slab cover is 4 cm and 6 cm respectively. So we can go to the figure next. So here it is mentioned that the cover for the stem is 4 cm and it's also mentioned that the cover for the base slab is 6 meter. Okay, so notice this figure. Here the ground is being supported by the right side and this is your heel portion and the opposite side is your toe portion. So this part we call it as the heel of the retaining wall and this part is your toe of the retaining wall. Various dimensions of retaining wall reinforcements are given. Okay, and this figure on the right, this shows the back elevation of the retaining wall, that is this side, the right side's elevation of the retaining wall is being shown on the right side. Okay, the total height of the retaining wall is 5.5 meter, height of the stem is 5.05 meter, distribution bars are given, additional bars are curtailed bars are given, alternate bars are given. There are many number of types of bars given here. Okay, so now you see the back elevation here. You can see that the rods or the steel rods are curtailed at 3 different lengths. One is here, one is curtailed here, and the one type of part goes to the entire height. Okay, so why does this happen? This is because, as you know, that the pressure of the earth increases like this. Okay, so as the depth increases, the pressure will also increase. Okay, as the depth increases, the pressure will also increase. You have learned this in earth pressure theories. So when it comes to the lower portion, more pressure comes and hence the retaining wall should withstand more pressure. For that we give more bars in the lower region. Okay, so from the you can see here now. Here what is given, you can see there are 20 mm diameter bars, 15 cm center to center curtail at a height of 2 meter. After that 20 mm diameter bars, 15 cm center to center curtail at 3 meters. 16 mm diameter bars at 30 cm center to center curtailed at 3 meters. And the last one 16 mm diameter bars, 30 cm which goes to the entire height. Okay, so these are the 3 main bars that has been given here. Along with that 12 mm distribution bars are given. Okay, on the front side, bars of 10 mm diameter is given on both the ways, 30 cm center to center. Now we will come to the toe slab. In the toe slab also you can see one rod here. Okay, and the next one you can see small distribution bars, and on the that is the top portion, and the lower portion you can see one rod which is going to the entire length. Next rod is given only on the front portion. Generally when you are designing a cantilever, bars are given in the lower portion. Okay, in the toe section more bars will be given in the lower portion. So this one is an additional bar which has been given. So 12 cm 12.5 and 12 cm 25 cm center to center is there. In addition to that 10 mm bars, 22 cm center to center distribution bars are also present. Okay, now we will move on and give you more details about this. We have already discussed that bars in stem right side, what all bars are there, bars in stem left side, what all bars are there. In the toe slab, what all bars are there, and the the top and the bottom also we have already discussed. Okay, so I already showed you a figure where the rods were curtailed in the back slab, back side elevation. So this is the 30-meter length. Okay, so your rods are being curtailed in three different heights. This was at 2 meter, this was at 3 meter, and this height is your 5.5 meter. And at the lower portion you can see an overlap of another one. Horizontal region is also given for the proper hooking of the reinforcement. Okay, so we'll again come to the picture so just go through all these dimensions. So first we'll start with the centering and shuttering. For stem, you need to find what is the amount of concrete you need. For the base slab, you need to what is the amount of concrete you need. And with that, you have to multiplying the cost, you can find the total cost. Okay, stem, as you know, the length or height was 30 meter. Okay, it is already directly given in the question paper. Okay, in the question. And the width of the retaining wall, its width of the retaining wall at the top is 0.23. Here the top width is 0.23 and the bottom width is 0.45. It's measured here. So you have to take an average for finding the width of the stem. Okay, it's given in the diagram. 0.23 at the top, 0.45 at the bottom. You just have to find the average here. Okay, and the height, it's already directly given. Height of the stem is 5.05. This height is 5.05. Okay, so from that you can find the volume of the shuttering and centering that would be required for the stem. Now we move on to the base slab. Base slab length is also 30 meter. Its width is 2.75 meter, that's already given, and its height is also 0.5 centimeter, that's also already given. You just need to multiply the length with the height to get the volume. When you add up both the volumes, you get around 88.63 meter cube of shuttering and centering. Concrete including shuttering and centering, and you are multiplying it with the rate that has been given to you, and the entire cost will become 2,65,033 rupees 65. Okay, the entire cost of RCC work including the shuttering and centering has been given here. Okay, I hope this is clear to you. Now we'll go on to determination of reinforcement. So determination of reinforcement, first is the stem on the right side. Okay, we'll take the stem on the right side. 20 mm bars. We already discussed what are the various bars. 20 mm bars up to 2 meter 15 centimeter center to center. 16 mm bars, the 3 meter 30 centimeter center to center. 16 mm bars, 5.505 meter 30 centimeter center to center, and the distribution bars are there. Okay, so we'll go one by one. So stem on the right side, 20 mm bars, 2 meter 15 centimeter center to center. So how will you find the length of that bar? So we know that length is 2 meter, plus you can see the elevation is extending up to this lower portion, so that is 0.45 meter. Okay, addition to that you have to add the hook length, that is 2 into 9 into 0.02, that is your hook thickness, that is your diameter of the bar, plus 0.5. Plus 0.5 means here you can see in this section there's a turn here. The reinforcement has been turned in the lower portion. That's an additional 0.5 meter you have to add to it, and from that you have to subtract the cover of the base slab. Okay, you have to subtract the cover of the base slab. In addition to the cover of the base slab, this bar, this lower bar, and this distribution bar has also to be subtracted, because you can see this 20 mm bar is lying over all these two bars. Okay, the 20 mm bar is lying over these two bars and the base cover. Okay, so you have to subtract all this and you will get the length as 3.23 meter. Please do the calculation again and check. 2 plus 0.45, that's your base slab thickness, plus this turn, that is your 0.5 meter, plus your hook length, that is 2 into 9 into 20 mm, minus this base slab cover, minus this distribution bars, diameter. Okay, so you have subtracted all that and you get the length as 3.23. And for finding the number of bars, we already saw in this figure, the bars are placed along the 30 meter length. So you have to subtract 30 meter minus 2 times the cover. Cover for stem is 0.04, so 2 into 0.04 divided by center to center spacing, that is 0.15, and you have to add 1 to it. So it is coming around 200.5 and you can approximate it to 201. You know the length of the bar, you know the number of bars. So you just have to multiply to find the total length, and total weight of the bar you have to find it from the weight per unit length into total length. Okay, I hope this part is clear to you. Okay, next we'll go on to 16 mm bars, 3 meter 30 centimeter center to center. It is similar to that. Okay, the center to center thickness distance is 30 centimeter because in between 20 mm bars are coming. So the 16 mm bars can be placed at a distance of 30 centimeter center to center only. Similarly, similar to the previous portion only, the length calculation comes. The difference is 3 meter is your height. Okay, it is curtailed at 3 meter. Previous case it was 2 meter. Here it is 3 meter plus 0.45 the base thickness plus 0.5 the turning on the base slab plus your hook length. Hook length, be careful, the diameter of the bar is changing to 0.1, changing from 20 mm to 16 mm. From that you have to subtract the cover of the base slab, reinforcements at the base slab, just like the previous case. Okay, here because the center to center difference is varying, the number of bars will also vary. Okay, so the length is 30 minus 2 into 0.04 as similar to the previous case, but the center to center distance here is varying to 0.3. You add 1 to it and you get 101. Okay, from that you can find the total length of the bars and the total weight of the bars. Okay, it's very similar. All the cases are similar. The only difference coming will be in the length calculation. Okay, next we will move on to the 16 mm full length bars. Okay, they are also vertical. So the length difference coming here is 5.05 instead of 3 meter. Here it becomes 5.05 plus 0.45 plus 0.5 that turning on the base slab plus your hook length minus the cover of the base slab minus reinforcement, and here you have to subtract the cover of the stem also because this was the bar which is going to the top layer. Here the bar is going to the top layer, but it is stopped at this distance lesser than from 5.05. This distance has to be reduced. Okay, so because of that the cover of the stem should also be reduced, and this is your total length. Okay, the number of bars will be similar to the previous case. So length is 30 minus 2.04 divided by the center to center spacing is 0.3, that has been given in the diagram, plus 1, and total length number of bars will be 101. Total length of the bars and the total weight of the bars has to be determined as per the previous case. Okay, so the total weight of 16 mm bars is coming around 1648.46. Okay, next we'll go on to the distribution bars, that is horizontal. Okay, because it's horizontal, the length you have to calculate is from the 30 meters. Okay, so 30 meter minus 2 times the stem cover, so that is 2 into 0.04 plus 3 times slab. So as I have already discussed in class, the maximum length of a steel reinforcement is generally 12 meters. Okay, so here you have to keep the reinforcement for 30 meter length. Okay, so for 30 meter, 3 times you will have to lap it because 2 reinforcements will be just 24 meters. So the third time also you have to overlap it. Okay, so while overlapping, the minimum, generally we tell the length of overlap is 40 to 45 times D. Okay, you can assume any value between 40 to 45 times D. Here I have taken 45 times D, where D is the diameter of the reinforcement. Okay, so here is 3 overlap, that is each bar will be 12 meters, so 3 times you have to overlap to get 30 meter length of the bar. So 3 into 45 into diameter of the bar, that is 0.012 plus there will be 8 hooks, because at each 3 overlap there will be 2 hook each, that comes to 6, and the end, both the ends, there will be 2 hooks, that is 8. Okay, so 8 into 9 into 8 into 90, that is your general length for hook, and that length will be around 32.404. And what will be the number of bars? It's placed in the horizontal direction, so you have to reduce from 5.05 minus 0.04, that is the stem cover, divided by center to center spacing is 0.3 plus 1, and you will be getting around 18. So you can find total length of the bars and total weight of the bars for that. Okay, next is the stem on the left side. So till now what we have learned, all the 4 reinforcement that we have calculated is stem on the right side. Now we are going to find the stem on the left side. It's comparatively easy because 10 mm bars 30 cm both ways, horizontal and vertical are both 30 cm center to center spaced. Okay, so for the horizontal bar the length is, as we have found just the earlier section, 30 minus 2 into cover plus 3 lap into 45D. Here the change is coming in the D. Please note that when there's a change in the diameter, you have to change the overlap length, that will change, the hook length will also change. Okay, therefore the length won't be similar. Please be careful, the diameter will change. So here the diameter has become 10 mm, and because of that it's 0.01 3 times for 45D. 3 laps are there, 3 times 45D plus 8 hooks are there, and that's 10 mm diameter. Okay, so the total length is coming around 32 meters, and the number of bars will be similar to the previous case, around 18 bars are coming. So total length of the bar is 18 into 32, and the total weight of the bars, 10 mm bar, weight per meter is 0.62, and from that you can find the total weight. Okay, so for finding the vertical bars, 5.5 was the total length. Okay, 5.5 minus 0.06, that is your stem cover. Stem cover minus your base cover and minus your diameter at the base plus 2 times the hook in the end. Okay, we are giving 5.5 directly because there's a turn on the left side. When you see the figure, you can see there's a turn here. So this 5.5 total length has been assumed directly. Okay, totally this 5.5 has been assumed directly. Okay, next similarly find the number of bars and also the total number of bars and the total weight of bars. Next we'll come on to the base slab. Base slab top portion, 16 mm bars is 10 cm center to center. Okay, you can see in the figure, this is the length of the bar. Just a second. This is the length of the bar. Okay, so the length is 1.4 meter plus 0.5 meter plus 0.5. Okay, so that is coming to 2.5 plus 2 times the diameter minus the cover in one side, because it's only this part you have taken. Okay, so sorry, it's 1.4 plus 0.45 plus 0.5. This 0.5 is the length of this bar which has been turned, but this length is 0.45 itself. Okay, so the total length is 1.4 plus 0.45 plus 0.5 plus 2 times of hook minus the cover in one side. Okay, so your length is coming to around 2.58. Number of bars is 30 minus 2 times the cover by 0.1 plus 1, because the base slab is moving in the I hope you can understand, the number of bars has to be calculated along this direction. Okay, number of bars is being calculated along this direction for in this case. Okay, now total length of the bars you can find out, total weight of the bars also you can find out. Next is the 10 mm bars, 22 cm center to center distribution bars. Okay, so this total length will be 30 meter plus this overlap length. This distribution bars is placed in the opposite direction along the length. Okay, is 30 meter plus 3 times the 3 times 3 into 45 times d, that is 3 overlaps are present, so 45 times d, and here the diameter is 10 mm. Okay, there will be 8 hooks as I have already discussed earlier, and minus 2 times the cover. Okay, so the number of bars, now you have to go on to find the number of bars. So the length which we calculated is 1.4 plus 0.45 plus 0.5 minus the cover. We don't add the hooks or any length for finding the number of bars, divided by the center to center distance was spacing distance was 0.2 plus 1, you add on to it and you will find the number of bars. Okay, so total number of bars is 11 into the length, and you can find the total weight of bars from the weight per unit length given. Okay, next we will move on to the bar. Next we will go on to the base slab, bars in the toe slab. Okay, so 12 mm bars, 25 cm center to center in the front portion. As I have already told you, in the front portion additional number of bars will be given because it's a cantilever type of a beam. Okay, the length is 0.9 plus 0.45 plus 0.5 plus 0.9 plus 0.5 plus 0.45 plus 0.5 plus 2 times the diameter. Okay, plus, see this, we are discussing about this bar now. You can see a hook here, right? So we are discussing about this bar now. Okay, 0.9 plus 0.45 plus 0.5 plus 2 times the diameter, 2 times the hook length minus the cover in one side, because cover is present only in this length. Okay, we need to reduce the cover only at this side, so minus the cover. Okay, and the number of, for finding the number of bars, 30 minus 2 into diameter 2 into cover of the base slab divided by center to center spacing is 0.25. You add 1 to it and you getting 121 bars. From that you can find the total length of the bars and the total weight of the bars. Okay, now we will go on to the next bar. See, you can see in the given figure 12 mm diameter, 12.5 mm centimeter, sorry, 12.5 centimeter center to center, and 12 mm diameter, 25 centimeter center to center is given. Okay, so here you can see on the right there's a figure that I have manually drawn and given. So if the bars are 12.5 centimeter distance, okay, if they are 12.5, 12.5 and 12.5 again, okay, actually their respective bars, the distance between their respective bars will be 25. Okay, so actually we have two sets of 12 mm bars. Okay, the first set of bars was placed 25, 25 and 25 apart. Okay, that we have already discussed. Now the second set of bars is placed 12.5 centimeter apart. Okay, so 12.5 centimeter apart from their other reinforcement. Okay, so actually we have calculated the weight of these reinforcement. Now we have to calculate the weight of the dotted reinforcement. So in effect, what will be the center to center reinforcement? It will be 25 itself. Okay, because we have the thick lines that I have shown here has already been calculated in the previous segment, that's the lower lap. Okay, what I am showing the next is the alternate bars which is shown in the full length. Okay, I told you, you need not, in the back portion you need not give more number of bars, you need only lesser number of bars. Okay, so in effect actually what is happening is I am placing the bars 12.5 mm center to center, but in effect the distance between them is becoming 25 mm. Sorry, 25 centimeters center to center. Okay, these dotted lines are the second set of bars that are going to be placed. In effect, the distance between the dotted bars, that's the second set of bars, is 25 centimeters center to center. Okay, I hope you got the gist of it. Okay, so the spacing is, even though it's given as 12.5, actually on field what is happening is the spacing is becoming 25. Okay, so when you find the number of bars here, you have to find the spacing, you have to put it as 0.25. Okay, Okay, you have to put the spacing as 0.25. So length of the bar is 1.4 plus 0.45 plus 0.5 plus 2 times the hook diameter. Okay, this is for the full length, that is, this is a full length minus 0.06, that is here cover on both the sides. Okay, so I forgot to put 2 times the cover, it's 2 times the cover on both the sides, and the number of bars is coming as 30 into minus 2 times the cover by 0.25, that's the center to center spacing, and that number of bars will come around 121. Total length of the bars you can find out as in the similar case, and the total weight of the bars also you are going to find out. Okay, last one is a 10 mm 22 cm center to center distribution bars. Okay, here as we have already discussed, so the 30 meter length plus 3 times overlapping plus 8 hooks and 9 times the 8 hooks into 9 times the minus 2 times the cover, and your total length will become 31.95. Okay, number of bars similar to the previous case, you have to find 2.75 minus 2 times the diameter or 2 times the cover by center to center spacing is 22 centimeter. You'll get around 30 number of bars. Okay, and the total length and the total weight of the bars you have to find like in the previous cases. Okay, after doing all this, you have to tabulate all these values. Okay, I'll be uploading this PPT in the drive in your classroom. A portion of the screen is getting cut in the presentation. Okay, so you have to tabulate this as shown here. Okay, for the examination, when you go from one page to the next page, find the total of the steel you have, total of the steel or the amount, it's the weight or whatever is being asked, you have to find the total here, carry it forward and write it on the top here. Okay, you have to write brought forward, BF has been written here, write it on the top and then start the calculation. Okay, so this is the overall I have calculated. I have got around 67 quintal of reinforcement. Please do the calculation again. Please try to do it individually. So 67 quintal, and the rate has been already given in the first question. You multiply with that and you will get the rest. Okay, if you have any doubts, please feel free to contact me. So this is about the bar bending schedule of the retaining wall. This is a very important question and it has been asked in all the university papers. Please study this.